After he's invested his money for 10 years, well, banks are fantastic. Now Peter has 9,000 USD to invest into the bank again, right? This time, he wants to explore a different investment option. He wants to explore continuous compounded method. Now the bank tells him, hey, listen, Peter, since you were a fantastic client for 10 years, we are now going to give you a 12% interest rate. And Peter's like, wow, okay, let's do this, right? So Peter decides he's going to this time invest for 12 years because he wants to retire. Okay, Peter's a young guy. Let's say Peter's now around 30 years old. So what formula can we use this time? Well, let's first give our values or our time frame a notation. We've learned before that the time frame would be considered T. We have our interest rate, which would be R, but our formula is going to look a little bit different now when it comes to continuously compounded interest. The formula we're going to use is A is equal to P E raised to the RT, PERT. Okay, you can think about PERT. PERT. So what is this E? Euler's number. It has an approximate value of 2.7 with an infinite number of decimals. So where can we find this E value? Well, on a normal or on a Casio calculator, so I use a Casio calculator. On a Casio calculator, we want to press alpha, which is on the top of the calculator, and multiply or scientific notation. So you press alpha first, and after you press alpha, you go find E. So it would be in like this little pink color. Now we've learned that the money Peter walks into the bank with, okay, that would be our P value. Now it depends what you're studying. So if you're studying like International Baccalaureate, sometimes the notations change, but it's the same method of mathematics, right? The method doesn't change, just the notations change. Now let's calculate after 12 years of using continuously compounded interest. Remember what I said earlier, that we want to always, not always, you don't have to do this. This is just to make things a little bit easier. When you take your interest rate to decimal. So I can say, well, 12 divided by 100, decimal goes 2 slots back, 1, 2, so 0.021. 0.12, excuse me. So the money Peter walked into the bank with was 9,000 USD. We're going to multiply that with E, raise it to the interest rate, which is 0.12, and we want to multiply that with the time frame, which is 12. So I'm going to quickly type this in on my Casio. I'm going to say 9,000 multiply alpha E, or alpha scientific notation. I'm going to raise that to double parentheses 0.12 and then 12. So after 12 years, Peter will have 37,986.26 US dollar. What a nice little investment, huh? After 12 years. Now, Peter can continue doing this if he wants to retire. Let's say after 12 years, he would be 42 years old. So if he decides to do this for another 12 years, whoo, Peter will be balling, right? He will be balling. So this is how we can calculate continuously compounded interest.